All right, so we're back to our hair salon. We've run it, and already we're seeing a horrible problem. The code doesn't even run very far, and we're getting some kind of awful looking thing. So basically what we're seeing is that the code is dying. What we are seeing is something called an exception. And when an exception happens, it often prints out something called a stack trace that tells us where in the code we are when it dies. The stack trace shows us the whole stack of methods that led to this point. It depicts main at the bottom because that's the first method called, and then called from there was makeNewBooking, which then called ArrayList.set, which then called a method called rangeCheck. And it's inside of rangeCheck that we died, and we can tell because that's where we see our exception message. And it's complaining that there is an out-of-bounds exception, an index out-of-bounds exception. So what is an index out-of-bounds exception? Well, we can see that we're trying to access item number 23, but there are only 17 items in the array. So basically, we're trying to access outside the memory that has been nicely allocated to the array list, and we're not allowed to access off the end of our array. So let's build some hypotheses for why this is happening. The first thing that we might have done is we might have passed the wrong thing into makeNewBooking from main. And for this, we need to check the parameter list and see that we're putting in the right thing. The second option is that we're not making the correct booking. It seemed fine the last time we looked at it, but this code has been changing a lot. So to check that hypothesis, we would want to look inside of makeNewBooking and make sure that the booking is being indexed correctly and that nothing odd is being done to it before the add method is called. Okay, so let's check hypothesis 1 first, that we did something wrong at the call site. And actually, we can see that's exactly what's happening. The booking time we're passing in is 22, and that's clearly a typo. It should be 12 if it's going to match the call right beneath it. Typos like this happen all the time. And this one's easy to fix. We can fix it just by changing this time to 12. So great, that's fixed, but we don't just want to stop there. That was pretty trivial, but we still want to chase down our second hypothesis just to make sure that we can cover it off. So I'm going to set a breakpoint here because I want to step into makeNewBooking and make sure that nothing else strange is happening. Okay, let's run the debugger and step into makeNewBooking. So here we have our booking time, and we can see that the customer is me and that all the elements in the booking are null. And then we're moving down and, oh, hang on a second, the booking time has changed to 13, which is really strange because it doesn't seem like we've actually done anything to the booking time. It seems like we're just taking the booking time, printing it out, and passing it into this set method. But in fact, if you look very closely, there's a typo here. And amazingly and annoyingly, this little variable is being changed because of this typo. Notice that we have all these plus signs that knit together the string that we're printing out. There must have been a couple here as well because we have 2 pluses right in a row. And 2 pluses in a row looks innocent enough, but actually they have great meaning in Java. If you put 2 pluses together like this after an int, it actually increments the value of that int. So this print statement was actually doing some unexpected work. It was actually incrementing the booking time value. Oh no. And if we keep stepping through, I actually end up being booked at 13, even though I was trying to be booked at 12. So let's stop execution here and erase this, and now we should be booking in at the correct time. And we can step through and see now that it's all happening correctly. Yep, Elisa is booked at 12. Now let's go back to main and run the whole thing to see what else is going on. And there are still bad things happening. So first there's this line in bright red, but we're going to ignore that for now and take a look at the output above it. We make a new customer, Elisa. The customer is booked at 12, but then there's no customer booked at that time. Okay, why not? I'm going to add one more call here to perhaps give us more insight into what's going wrong. I'm just going to try looking for a booking that doesn't exist. Let's verify a booking at time 13. Ooh, and now we have another problem, something called a null pointer exception. A null pointer exception happens when you try to access an object that is null, so it hasn't been filled in with all the lovely details of construction. It's just sitting there being a pointer to nothing. If you try and call a method on a null object, you will get this null pointer exception. So we have a couple of issues with verify booking. It's saying that there's no booking when we know there is, and when there is no booking, it really gets upset. So both of these problems seem like they exist within verify booking. So let's kind of make a blanket hypothesis about these. It seems like something is going on with the retrieving of bookings inside of Verify Booking. Now, this is not the best, most well-formed hypothesis, but it at least gives us a starting point for where to look. It seems like the customer name isn't being retrieved properly for some reason, maybe. And then we have the second problem, which is this null pointer exception. So we're going to chase these down. Let's put a breakpoint at the first call to Verify Booking. And we see our salon, and it has a booking at 12. Okay, so let's step in and through. So this is a valid booking because we know that Elisa is booked at 12. And we can see that this variable booked customer is the object customer 440, which is Elisa. So we should go into the second case here where we have a customer with the correct name. But if we look what's actually going on, we're going into this first case. Why is this happening? Okay, if we look carefully up here, it turns out that we have a typo in our condition. Instead of checking that the customer is null, we're checking that the customer is not null. We're doing the opposite thing to what we should be doing. So we're going into the wrong branch of our conditional. We can change this to check that the customer equals null. That's when we want to say there is no customer booked at that time. So now if we rerun this, we've actually solved both problems, just with fixing that one typo. We have a confirmation that Elisa is booked, and we've also gotten rid of our null pointer exception. How did we manage that? Let's change it back to how it was and put the breakpoint at the next line instead to investigate. If we step in here, we can see that this time the customer is null, so the first test fails. And then in the next conditional, we're calling this method on a null pointer. Calling a method on a null object or on a null pointer will kill execution. So we weren't catching the null case correctly. So by changing this to equals equals, we've actually solved both problems. If it's null, nothing will ever be called on it, which means that it will not crash. And if it's not null, then we will come in here and check the name. Now let's run it again and chase down this craziness that's happening here. So you can see that these exceptions, when they come in, are not actually very polite. They just kind of overwrite all your output. Okay, now we have another kind of exception, an index out of bounds exception. We're indexing at 17, and the size is 17. Now remember, in Java and programming in general, arrays are indexed starting at 0. So the size of the array is actually one more than the last indexable item in the array. So we shouldn't be indexing past 16 in this array. So what's happening? Clearly the wrong number of elements are being initialized in this array. So hypothesis 1, the initialization is wrong, and hypothesis 2, it isn't being accessed correctly. So let's take a look at initialization first. We'll go into Hair Salon and see how it's being initialized. And sure enough, we can see that we have yet another typo. We want to be able to index all the way up to 17, but we didn't allow that. This should be a less than or equal to sign. We can run that again and see if it helps. Oh, no, it actually doesn't help. That's interesting. Why not? Now we're indexing at 18, and the size is 18. Well, we know that this was wrong, but it seems like something else is wrong as well. So let's investigate our second hypothesis. Let's see where it's being accessed. To find out, we can actually look right here. It says it's being accessed in print booking list. We can look in here and see that it says less than or equal to 19, another typo. Typos will totally get you in programming. Human error is no joke. It looks like maybe in an earlier version of this, we wanted our hair salon to be open until 7, and then we changed it to be open until 6 or 5. And we have all these, what we call magic numbers, hanging around. Numbers that we've put in literally, and then we have to go chase down anytime we want to make a change. We don't really want these in our code. So what we want to do is replace these magic numbers either with a symbolic constant, or we want to calculate the actual size of this array. So here we'll say when I is less than bookings.size. And then it will never index off the end of the array because we'll always be indexing at least one less than the size. So now if we run it, we've finally eliminated all of our errors. We're indexing right up to 17 here on our booking list, which is what we want, and not past it. Now, really, we shouldn't be using a magic number here in our initialization either. Instead, we could add a text field called max time and set it in the constructor to be 17. And you could actually take this in as a parameter if you wanted to make salons with different numbers of hours. But for now, we'll just say 17, since we're only using it one time. And here, I'll say I is less than max time. So now if we want to change our salon hours, we only have one place where we'll need to go. This will protect us from those pesky typos, and it's much better programming style.